And Elon's work revolves around implementing support for scientists to use OpenSpace for their visualization purposes. And so he's going to talk a bit more about that as he goes through two profiles in OpenSpace. And he's going to be using OpenSpace version 20.1, which I'll put in the chat if you're not familiar with it. So Elon, take it away.
Yeah, thanks. Yeah, so the sort of idea we have is that you guys have already either used some of this stuff or at least used OpenSpace before, um, or maybe you know more about space weather than I do and have not used OpenSpace before. So it's going to be like a little bit of a mix of both, but um, I'm going to go ahead and share my screen. Um, Here we go. So I'm going to start with um, this profile called the Bastille Day 2000, um, which is probably the heaviest in terms of data that we ship from OpenSpace as a publicly accessible profile. And this is more or less what you're gonna see when you start the profile. Um, oh, and also I just want to say, like, this is not like a presentation. If you have questions, please interrupt me, um, or tell me if what I'm saying is wrong. Doesn't have to be a question. Don't wait with your questions until the end. Very informal. I'm here to answer your questions. Like, that's why we're here. Um, so yeah, okay. Um, but yeah, when you start the profile, this is what you'll see. Um, a green sun with some blue stuff. If you don't know what that is, I understand that that might be confusing. So what I usually do when I start this profile is to um, like toggle some stuff on and off. Usually start with a clean slate and start showing the stuff like one visual at a time. Um, and a lot of those toggles are made into actions here in this menu. Um, so I'll back it up a little bit more and I actually say what this profile is genuinely for. So you can see that the time is set to July 14th, 2000, which was um, a massive CME, coronal mass ejection, that happened, and it's probably the most studied eruption. And it hit Earth and had complications. So it's very well studied because of that. Um, and those visuals like really show this CME exploding and showing different aspects of it, um, and yeah. So again, those actions for toggling stuff on and off you can find in this menu. Um, so here, for example, it's the EUV layer, which is extreme ultraviolet. So that's actually the green texture that's on the sun. Uh, that is um, a simulation, so it's not observation. Um, and so are most other things like these magnetic field lines and this blue haze, which is a density visualization using volumetric ray tracing. Some other actions that are in here are loops set to like be right before the eruption and continue either for a bit longer or shorter and different speeds, like simulation speeds. So I like to run the one that's really fast and a bit longer, like this one. So Oh, I have time paused also. So I'll start it now, and this is basically what you'll see um, yourself when you run it. And the eruption starts here at like 10 past 10. And yeah, there's a lot going on here. So again, what I like to do is toggle a lot of these stuff off and show them one at a time. Uh, those actions, I also have them on hotkeys, which uh, I know them by heart now, but you can also find them here going into this menu at the bottom left, find hotkeys, and a lot of these like letters are different toggles. So O for these ones, P for plane, um, etc. You can explore there more if you want. Um, so let's start with this blue haze. So this is like showing the density of the mass that the CME is shooting out. And I'll get to this white blip in a moment. It's a speed of light indicator. I'll turn that off for now, but you can remind me to come back to it. So this loop should be restarting here soon. Actually, I'm gonna do a different one that's at 15 minutes per second. So we'll see it loop a bit faster. So with the density, like we also have these magnetic field lines. So I mean, I'm not a scientist, so I don't want to say like too much of why a CME is happening, but um, basically, I'm gonna try to get it here. Basically, it's like tangled up magnetic twisting that's um, reconnecting, and a huge like burst of energy is released. That's that's the extent I'm gonna explain it. But yeah, so there's these field lines are basically traced along the magnetic field lines. Um, and there are different fields that you can trace lines in, but these are, yeah, the magnetic field lines. Sorry, I'm gonna mute my phone also. Any questions so far? Again, go ahead and interrupt me if there's any questions.
Yeah, where
No,
did the data come from in this one? Do you
Yeah,
remember?
great questions. So all of there's like a couple, mostly the visuals in this profile are from simulation models, and there's like a couple of different models being used here. The density and these magnetic field lines, as well as this um, this green texture, the EUV texture, they all come from a model called MAS or MAS, which is a part of core hell. I can maybe type that in the chat. MAS, part of core hell. And that is a model produced by Predictive Science Incorporation in San Diego, also known as PSI, Predictive Science Incorporation.
And so I guess
So
the question, the question is that that's not a model that's being rendered inside OpenSpace, right? That's not a model that we can export as an OBJ
yeah,
or something.
no. So um, yeah,
Different
this is you
use
using
of the word
the
model.
yeah. So this yeah, it's a simulation model, a simulation software. Um, so I'm using the
Like theoretical model, not 3D model.
yeah, exactly. That's a good way to put it. I'm using the outputs of those simulations to create visuals, and those are what you see.
Got it. Thank you.
Yeah.
And then do you want to just briefly describe what those output files are, just quickly, like that we read in OpenSpace, so Jeff can get an idea? Like those, the FLS files or something, just in like 2 sentences.
I mean, most simulation models outputs like a sequence of volume data. They have different like domains, like how big they are, their resolutions. Some have like very interesting grids that are like high resolution closer to the sun and less resolution further out. And they all do like different assumptions and different inputs before you run the simulation. And yeah, that's kind of the extent I use the models. Like I don't run the simulations myself. I just create features and content that user or scientists and my boss tells me to.
Yeah, they
So
have chosen all the parameters of the model,
exactly,
and
So
you're rendering their output.
yeah.
Or we are.
A couple of years ago, we had some students who started, and I helped out as well with this visualization. I don't know how well that comes out, but it should be pretty good. These are, we call them Flux nodes. They are also from Predictive Science Incorporation. And we like to describe these as like detectors, detecting the SCPs. I forget what that stands for now.
Something energetic photon.
Yeah, particles. Yeah, I forget. Maya, what's SCP? What's it stand for again? Solar energetical particles. Okay. So I mean, they're a simulation output as well. And their color sort of indicates the flux value or like the proton intensity. And they stretch all the way past Earth. So I'm gonna zoom out, and out here they'll look like lines, but you saw that they were all like dots or nodes. So if I start time here again and start to loop over, you'll see them expand, and they're also moving with the magnetic field. But yeah, it's not so much that that you see them like lighting up and sort of moving towards the Earth. That's interesting. It's the color you should look out for. So like the higher the brighter color, the higher intensity value. And yeah, that comes with this little color bar at the side. And yeah, again, that's a project that happened a couple of years ago.
Can you also just show that view from the top down to show how it turns with the rotation of the sun? The
Yeah,
Conquer spiral.
yeah, exactly. Yeah, I mean, yeah, you nailed it. This is like a spiral because of the rotation of the sun. And yeah, that extends on this side as well, of course.
Does the model of the sun in open space also rotate?
Yes.
It has a constant rotation. It doesn't do differential rotation, which
Yes,
it should.
okay.
And yeah, like since we're on this top view, there's also these planes. Maybe you saw them when I first started the loop, and you saw all the visuals at the same time. So there's this plane. So we can like think of this plane as those flux nodes just projected down on the equatorial plane of the sun. So here I like to show this one when talking about like how widespread the CME was. Like this little dot here is Earth, and this is like the whole inner solar system, right? So it's like so massive. We also project it on orthogonal plane on this side.
And this is the same data as those flux nodes, right? Just
It is,
represented
yes.
differently? Awesome.
Yes, yeah. So having like all of these visuals on at the same time is like not great. Like it's so overwhelming. You don't see what's happening, right? So it is good to like if you are to use this for some presentation or anything, like yes, you can use these actions here. And if you prefer to use different keybinds, like we can help you set that up too. But if you just want to use the ones that's in there, sorry, I'm not trying to toggle these off. Again, you find them here under this menu, show keybinds, and you can click around to find which ones you want to use. Under this EV texture, there's also some other textures, and these are called magnetograms. There's a couple of different options here. I'm clicking I to toggle or like to go through these. And basically this is also from I think it's from the same model as this one. And a magnetogram is showing the different magnetic poles or magnetic poles in like on the photosphere of the sun. So I think red is positive and blue is negative, but it could be the other way around. I get that mixed up. So yeah, again, there's like some different options here. Whatever you want to use for your presentation, it's whatever you want. So let me see. Yeah, so last thing on this profile is at Earth. Yeah, here on this focus menu, you can choose different target. Yeah, in this profile, we for Earth only use this one time step of I mean, we kind of call it just a generic magnetosphere. And these are also magnetic field lines traced so that it's showing the closed field lines, like the ones that loops in from North to South Pole, that are the furthest away from Earth. Like if you were to go a little bit further out, they would no longer be closed or like in a loop like this. And in the menu, you can find what these colors means. So you'll navigate you'll navigate to Earth and magnetosphere, color, and you see here that it's colored by speed or velocity between 50 and 300. That should be kilometers per second, I'm pretty sure. And that is, again, something you would have to check in the model description to verify. And this model is Batsa-Ras, which is part of SWMF, which I think is the most well-known magnetosphere, like a global magnetosphere simulation model. Maybe we can have a link to that too in the chat. SWMF. Okay, so I think that was everything I was going to show for this profile, unless I'm forgetting something or anyone has any more questions.
Did you want to go back to the speed of light indicator quick?
Oh yeah. that one I usually want to show together with the with this cut plane. So it's called speed indicator, and you can search for it here in the GUI. So this is a little blip. It's moving at the speed of light. And I like to show it together with this cut plane on this top view, because then you can like compare how fast these SCPs, these highly energetic particles, reach Earth. So I count about 3 or 4 times I see the blip reach Earth before the SCPs reach Earth, meaning they move towards Earth at the speed of a quarter of the speed of light. So super high energy. Yeah, that's what I use
And
it
that's
for.
completely dynamic with the time, right? Like and I see you're going through time really, really fast, but normally I
Yeah,
would want it to go slower, right?
yeah, sure. And again, there's different loops you can set here if and they all say, like, I think I'm running this one now 15 minutes per second, but yeah, you can run it at 4 minutes per second, and it's more yeah, maybe easier to follow along what's happening.
And then is the Earth magnetosphere dynamic too, or is that just static?
In this profile, it's only one time step, so yeah, it's static. We can maybe move on to the other profile where we do have a sequence of the Earth's magnetosphere, and you'll see that when a storm hits the Earth. Anything else in this profile, or should I shut it down?
No, I think it's good. Go to the next one.
Okay.
So this is a good question of you have to shut it down to start up the second profile. Like you
Yes,
can't
if you
combine
want to,
them.
you can. We do separate them because all the content in one scene or one profile would be like overloading your RAM and stuff. So, and there's also, different interests. Like maybe you want to see new horizons and don't care about space weather, right? Then you don't need those heavy data sets in there. But yeah, you can combine them and you can create your own profiles in here too. The ones I'm going through are just the ones that we've created that are publicly available through OpenSpace directly. Yeah, so this is also in relation to what we just talked about. This is a different event, a different CME.
What's the name of the profile?
Yeah, the profile is a Solar Storm 2012. And yeah, it's actually the same date as the previous one, just 12 years later. And this one has like a series of CMEs, ending with a massive one that luckily did not hit Earth. This is just how it looks like when you start this profile. You'll see these red lines and these white lines. And they can like definitely need some explanation, right? So, but yeah, there's a bunch of assets in this. So some are, you see Fieldlines for Bats and Rust. That's the same one as the static one I just showed earlier. But in this profile, it's a sequence. Enlil is this other one that you see on screen now, which reach from the sun and beyond Mars in terms of domain of the model. And yeah, again, there's multiple assets with this one too. And these white ones are, one of them is this one called just Earth. And those are just there to highlight the field lines that crosses Earth. So they're traced from Earth in both directions, basically. And the other white lines are these ones, Enlil Stereo A, So a spacecraft in orbit around the sun, which also measured data for this model input. So those are the ones there on the right. And then if we zoom into the sun, there's another model called PFSS, which is it's a smaller domain. This one has some like sort of particles flowing around them, which is not like accurate in speed or anything. It's just an indication of which direction particles are flowing in the magnetic field there.
For this one, is it also safe to say, hopefully, because this is what I often say about this one, is while it appears to be moving, it's not actually tied with the event. Like
Yeah,
this is just an
that's right.
average, whereas the other stuff that's moving, like they're sequenced together.
Yeah, that's correct. Yeah, this is just one time step, generic, if you want. So since it's not a sequence, I'm going to turn it off for now. And same thing for this one. There's some actions that are interesting to use for this one, specifically two loops. And since they're one model for like around Earth and one for the sun, they have different cadence, different time resolution. So there's one loop for Enlil, which is this solar system, like the big one, and then Batsaros, which again is the magnetosphere one. So I'm gonna hit the loop Enlil button here, and we can see the event before we talk about anything else. The color map for these ones are also colored by speed, and brighter colors meaning faster speed. So there you see one CME, kind of not a big one, but you could definitely see how it like disrupt the magnetic, or I should say the magnetic field in the solar system. And that was the second one, and then I think here's the big one. So yeah, you could tell that was not directed at Earth, luckily. Any questions on that one? If not, I'm gonna go into Earth, show the Batsaros one.
Maybe if we can look at the ecliptic just to show the vertical extent of the model. If you
Like
rotate down
this
to
way?
see how thick
Yeah.
it, yeah,
Yeah, it is. I mean, the model definitely has data like or simulation output in more than what is visualized here. It's just that we've chosen to trace field lines that are in this plane more or less.
Also, I should ask to be explicit. I never did, but I always just assumed in this case the yellow means higher intensity and
Exactly.
white.
Yeah.
Yeah, okay.
Yeah. And again, you can see exactly which colors these are. Oh no, I opened the wrong one. And my GUI is really slow for some reason.
This also means you can customize the colors, can
Yes,
is that right?
you
Okay.
can. For a color map, it's a bit trickier. What you can do is type in a path to a different color map or transfer function. I want to show you, but I don't know. I've had some issues with my computer the last couple of days, where the GUI is just super slow. So
It's also safe to say that's a more advanced thing because you'd have to
for
like
sure, yeah.
create the color map file already.
Yeah, there are right, I'm not showing my full screen, but like you can find, like if you look at that color map, like in the GUI where it is, you can look in your local file explorer to find where it is, and there are a couple of options in there that you can try if you want. You can also set to just color them by one color, and then that is a bit easier to manipulate or modify yourself. Like these white ones, traced from Earth, they're completely white, and you can change that color if you want. We do have our own like binary format that we call the OSFLS for OpenSpace Fieldline sequence. That I like is to minimize the data load, because having it with a sequence is also you know, each time step is its own data file, so it can be a lot of data if you have a full sequence. But we do also have a JSON format that's more humanly readable, so you can see in like which step in the file, like you can read the file format and create your own basically if you have Fieldline data. And of course, I'm here to like help anyone with getting people's Fieldline data into OpenSpace or any other data for that matter. Because of course we want more people using this, even for scientists. Like if scientists want to visualize their data in here, that'd be cool. So I'm gonna ask Micah to go towards Earth, and we'll show the Bats Are Us sequence. And yeah, there's also a loop for that. So because it has a different cadence again and time range of the sequence compared to the Enlil model. Yeah, so he's highlighting that we're running at 23 minutes per second here. So it's also different, like depending on how fast we're running it. So there's actually two data sets visualized in the magnetosphere here. Maybe if you want to pause it, Micah, and maybe toggle off at least the white lines for under heliosphere, and then at the bottom somewhere. Oh yeah, these ones, yeah. So you see the green long ones are actually not traced in the magnetic field lines. They have a couple of different names. We call them flow lines here in the GUI. But essentially in the simulation output, there are different fields that you can use in different ways. Like we've traced field lines in those fields, right? So these are traced on the velocity field and colored by velocity as well. And then closer to Earth, you see the magnetosphere, which is magnetic field lines, again, traced like the furthest closed field lines. And those are, yeah, those ones. Those are colored by temperature. And again, you can go into the GUI there and click under color to see like which range it's using, and
Question. I've
yeah,
never tried changing it to speed. Does that work? Does that do anything?
Yeah, it should work. Yeah, try it. So the lines are still traced in the velocity. I mean, magnetic field line, magnetic field, but colored by the speed now. So it should match up better with the flow lines because they're also visualized or colored by speed.
And when you say speed versus temperature, that's the speed and temperature of the particles that are coming off, right?
I think so.
It's the temperature or the speed of a theoretical particle that lives on that magnetic field line at that position.
Yeah.
Got it. Thank you.
Temperature is a bit different though, and density, because it's like in that grid cell, like what is the temperature in this data points, which is, not necessarily referring to particles. But I mean, for dense, yeah, I guess there's part of that equation too, right? How many particles are in the
What is it, the
cell?
temperature of that cell, if not the temperature of the particles in
Oh,
that
well,
cell?
yeah. Well,
Well, then my follow-up question is to find out more, we should just go to the data source to see what we're seeing. Because,
yeah, or
I mean, it
read the
looks amazing,
model. Yeah.
right? Yeah, it looks awesome, but
Yeah.
it doesn't mean anything if I can't tell people what it means, right?
Yeah,
Yeah.
exactly. Yeah, if you want to know more about like yeah, say like the unit that it's using or more like what is the max temp, like min and max and stuff like that, like or read just in general more about the model. Yeah, I would say go to look up the model and read more on it. So I actually noticed something when you were in the color menu there, Micah, that you're not seeing all of it. So I think you're on like a user setting. Yeah. So if you change that to, I think, advanced user at least, you should be able to go back to here and see and change the range of in this case, temperature. So which will, I mean, this is like really advanced and I don't expect anyone to use this really, but if you want to play around with it and see how that works, you can.
I believe we do have a bug in version 20 as well that the values don't update properly, if I remember correctly. I think we have fixed it since, but
Oh, okay. And yeah, there you also see the path to the color color map or transfer function. Okay, so I think we're done with this profile unless there's more questions.
well, just to make this, like, for example, there is nothing preventing someone from including this temporal Batsaras in some other profile as well, right?
Yeah, exactly. Yeah, it's true with any asset in OpenSpace. You can include them in any profile or make your own, or drag and drop is also an option, right? So,
And
If
this is
you're not
all,
able to speak to it, it's okay, but since this one is there included in it
oh yeah,
and it's in our profile, are you able to mention how this is like some sort of showing where
yeah,
the two meet or whatever?
yeah. So like compared to the closed, like the looped magnetic field lines closer to Earth, those have been like undergoing a algorithm to find like the furthest closed field lines, whereas these blue ones is like an old developer who's no longer working with OpenSpace. It's more his old like test. I think he put in manually which seed points to start the trace from. So some of them are closed field lines, some are open. So it's why they're not enabled on default, because it's more a test, but they're still interesting to show because now those are magnetic field lines as well. So if you start tracing those further away from Earth, you'll see how the magnetic field looks there as well.
It was like an experiment to find those last closed field lines, like automatically, which works. So. But
Is that what the experiment was? I didn't know that.
yeah, it's basically the predecessor to Philip's work. One of the students.
Yeah, okay, cool. All right. So, yeah, those were the two profiles that are, publicly accessible now and have been for quite a while. If my OpenSpace wanna work again, I'm happy to show some work that I'm working on now. And it's a different simulation model, which is focused around the sun. It's called WSA. I am opening my OpenSpace here.
Just real
But
quick, those are all
yeah.
locked to those times, right? All of those visualizations are time dependent.
Yes. So yeah, if you like see an interesting little thing in the magnetosphere and you want to like and it swishes by because you're running too fast, you can go back in time and find it.
Well, I was
Like so.
thinking even just that static one from the Bastille Day one, that would be nice to show, to have it, decouple it from the time so that you could show it any time you want, since it's static anyway.
That is how it works right now.
Oh, so that one is not time dependent. Got
No,
it. Okay.
correct. So yeah, that's what we just say. It's a generic magnetosphere.
Yeah, no, that's good to
Yeah.
know. Thank you.
Yeah. But it is, to me, at least, pretty important to tell that, or maybe it depends on the audience, but it is from a simulation still. Like it is a real simulation output, which is a specific time. It's just that we're showing it for a longer or like infinite time period.
Yeah, great. Thank you.
Yeah.
Which might be important. For example, if you're using it in your show, Jeff, for example, that I don't know at which time that what was created, probably in summer as well, which means that if it's winter in the open space time, it will still show it. It'll still the magnetic field will still go outwards from the solar system, but it might be that a magnetic field might be or like oriented the wrong way, for example. So that would be good to highlight in this case.
Yeah, I totally agree.
Okay. Yeah, I'm happy to show a little bit of the sort of results of the work I've been working on. It's more or less finished, so it's pretty interesting to see as well. The main work I've been doing on this has been what I've been calling a dynamic downloader, which basically this model outputs simulation output data on a regular basis with, I think, 1 hour cadence or maybe half-hour cadence. I don't remember right now. But so to get like the relevant simulation outputs depending on what the time is in OpenSpace, I've implemented so that it fetches the most relevant data. So like I'm starting this on a random date here, but we can go to now and it will show the magnetic field lines of the sun and this weird looking magnetogram. the magnetogram is actually has multiple or I think it's actually wrong to say that this is a magnetogram. It's I'm trying to find the setting for it here. But yeah, the file format is called FITS, FITS, and it has different layers. So this one is just one layer. And then this one, number 5, I'm gonna try to get the actual names of these into the GUI. But yeah, this should be the magnetogram. And similar to the first profile I showed, it's showing the magnetic polarities on the sun's surface. And there's 9 different of those layers. They all look different and mean different. I'm not sure what the other ones actually represents, but the magnetogram I do know. And I've also added for this that you can where is it? Yeah, there's a filter if you want to see it like blurry like this, like more or like this, like pixelated. And there's also this one you see has a color map, and there's also a toggle button in the GUI where you can toggle that on or off if you prefer to see it black or white, black and white, or with color. And then there's also different different field lines. So these are one example. These are filtered to and like well picked out field lines with the algorithm. Or there's also these ones that are like on the sort of ecliptic plane. So yeah, again, this is cool because it's like fetching the latest data, so you can see like what the sun looks like right now, more or less. With it's still simulation data, right? But in theory, this should be working for other models.
So this is today's?
Yeah.
Cool.
This is the very latest simulation output from this model.
And would we be able to go back to a time when it was a solar minimum to show the difference between the solar minimum and maximum?
If for this version of the simulation model is old enough.
Yeah, I mean, I realized as I was asking it, I didn't think you had 8 years of data back there, but
yeah, it might be like we can try 4 years ago.
oh, I didn't even mean for you to like try it right now. I just meant like in general, I was thinking of a concept like I could jump multiple like a year and see like watch the activity grow or something.
Yeah, in theory you should, but I think
Cool.
just for this version, there's not. It's a newer version.
Yeah,
So maybe it doesn't have enough
that
data for
hasn't
that
been
yet.
run. 8 years from now, I can do that.
Yeah, sure. But yeah, you can think like the Enlil model that we showed actually couples with this WSA model. So if we create like a similar algorithm to create the field lines for that, we could have like the whole like inner solar system modeled with magnetic field lines to show how it looks like right now. So that's the kind of stuff I'm working on right now, and I realize we're 1 minute over already.
Yeah, this is great. Thank you.
Yep, thanks.
Thanks, y'all, for joining. I hope you're excited to visualize some space weather in open space.